All right, so the next unit that we're going to do, or section of this topic 4, is on ionic compounds. So far we've gone over molecular compounds, and now we need to go over ionic. It says, recall that an ionic compound forms between a metal and a non-metal, or a metallic element and a non-metallic. So what I've got here is I'm showing you that a metal is a positive, and a positive is a cation, where a non-metal is normally a negatively charged ion, and it's called an anion. All right? So it says, in an ionic compound, electrons are transferred between atoms, allowing each atom in the compound to achieve a full valence orbital. This results in a strong attraction between each atom. So when you're sharing, you don't have quite as strong of an attraction like you did in molecular. In ionic, it's a really strong attraction because you're actually transferring an ion or an electron from one of the elements. Okay. It says ionic compounds tend to be good conductors of electricity because they form ions with opposing charges. So they're good at conducting electricity because what we'll learn later on, possibly it would be in Science 20 or 30, that electricity is the transfer of electrons. So when we're transferring an electron like this, electron from your sodium to your chloride, that transfer, we can harness the energy of that transfer, and that's really what electricity is. So these are really good conductors of electricity, ionic compounds. So good conductors of electricity. All right. So how do we name ionic compounds? Well, the names of binary ionic compounds, and binary means two, so two elements in these types of compounds. Follow these rules. So first you write the name of the metallic element first. So metallic would be that metal, and the metal is always going to come first in the compound. Then we're going to change the ending of the name of the second element to "ide." So something is going to be, we're going to name the metal, we're going to name the non-metal, and then we're going to change the ending to "ide." And then it says polyatomic ions are named according to the table in your data booklet. I don't believe you have a data booklet that I've given you, but I will post this for you, the polyatomic ions. It says, note that subscript numbers in the chemical formula that are used to indicate the ratio of ions in the compound are not included in the name, so no prefix is necessary. So I'm just going to give you an example of that. If we had... Okay, I went way too far. Really, really far. Yeah. So if I had something called, now I gotta think of something in my head. How about Li2O? So if we were going to name that, we would look up what is the name of Li, what is the name of O. And this number here, it would not affect, we don't need to use prefixes like we did in the past. So if we were using these naming rules, we would go name the first element, Li. If we look that up, that's lithium. Name the second element. The second element is O, which is oxygen. Now here in number 2, it says change the second element's ending to IDE. So we would take off actually all of that, and it would become oxide. All right, so lithium oxide, that's it. That's all you gotta do. So we're not saying dilithium oxide like we did with the molecular compounds. We're just naming it, writing the names of it. The numbers don't matter, and I'll explain to you in a minute what the numbers actually mean. All right, so these are our practice ones. Let's name them. So again, this is as simple as looking it up on the periodic table to find its name. And I normally have in my notes, actually no, I'm not going to do it that way. I think I have it in the pictures. I'm actually recording this in my car right now because there's people in my house ripping the floor out and it's really, really loud, so I couldn't record this video for you. Okay, so our first question here is LIF. So if we go to our periodic table, we need to find Li and we need to find F. Li is number 3 right there, and that stands for lithium. So just draw an arrow here. So the first Li is lithium. Then we got to look up what the heck is F. Notice that the first element's always going to be a metal, the second's going to be a non-metal. So when we're looking for this on the periodic table, something that's a non-metal is actually right on the right-hand side here. So it narrows it down for you, especially when you're not so familiar with the periodic table as of yet. So F is number 9 right there, and it's fluorine. So this would become fluorine. And our second step of naming our elements here, our ionic compounds, is that we need to change that ending. So it doesn't become lithium fluorine, it becomes lithium fluoride. So all we're doing is changing that N to D, and maybe I should write that a little bit better. If I can. There we go. All right, our second one here, this is Li and O. We already know from the question before that Li stands for lithium. And then O, I hope you already know what O is. O is oxygen. We actually just did this one. Oops. That's the one I made up on the last slide. And then we change that ending to IDE. So it becomes oxide. And then that's it. Lithium oxide. CaI. First got to figure out what Ca is. It's a metal, so it's going to be on the left-hand side or in that past the staircase. There's a lot of metals on the periodic table. But calcium for us is in the second row here, second column. If I can get to it. Why is it cutting it off? It's number 20 there. It's Ca and it's calcium. So this becomes calcium. And then our I, we've got to look that up. And again, on the right-hand side, just in that light green area is where you're going to find these non-metals, and that's iodine, number 53. All right, so calcium iodine, then we just got to change that ending to D, so it becomes iodide. We don't need to say diiodide. These numbers are not important when we're dealing with this, okay? The next one, Kp, K3P. We've got to look up what K is and what P is. So first we'll look up K. K is going to be on the left-hand side of the periodic table. It's actually number 19, and it's potassium. So let's go write that. Potassium. And then we need to look up what P is. P would be on the right-hand side of the periodic table, and P is number 15. Number 15 is phosphorus. So it becomes potassium, phosphorus, but we're not done because we need to change that ending. And on these ones, we take off literally the "-ous and we add "-ide". So it's not phosphorus, it's phosphide. Potassium phosphide. Then the last one here, MgN. We got to look up what Mg is. Mg is on the left-hand side of the periodic table. Mg is number 12, if I can see it here. And that's magnesium. And then N, if we look that up, that's on the right-hand side, and it's number 7. It's nitrogen. As you do these, or as you get more used to the periodic table, you might not even need to look them up. You'll start to remember the symbols that correspond with different elements. So magnesium, nitrogen, not done yet. We've got to change that ending. So it becomes nitride. Right? So that is that one. That is our practice on our ionic naming. All right. Next one we're going to write them from the words to the formulas. So it says, note that unlike molecular compounds, we do not have prefixes telling us how many of each atom there is in the compound. Instead, we must add subscript numbers to balance the charges of the metallic and non-metallic. The overall charge of the compound should be neutral. So this is probably, again, the most complicated part of ionic naming, because we're going to have to go from words or names to formulas, and our formulas are actually balanced. They have charges that are balanced, and that's what those numbers represent. So let's do, well, I can do at least the first one on this page. I'll do it at the top here. So we're going to do number 1. Number 1 is magnesium chloride. All right, so that's magnesium chloride. So our first step whenever we're doing these is we're going to have to look up what the symbol is for magnesium and what the symbol is for chloride. Okay. So we just did magnesium actually in the last question, I believe. Magnesium is number 12 on the periodic table, and it's Mg. And chloride is over number 17, and that's Cl. So I'm going to write Mg, and I'm going to write Cl. I shouldn't have wrote them that far away from each other. So this might be, some of you might be like, oh yeah, that's good, it's done. We wrote down the symbols, but we need to make sure that our charges are balanced. And I'm going to tell you that it's not balanced right now, but we need to, you have probably no idea what it means to be balanced. So I'm going to show you. So this is really important. Remember when, and I have it on this picture, remember when I told you like the first row has +1s, second one +2s, and then you see those charges that I've got over here? Those are going to come in handy right now. So for magnesium is way over here, and it's in the +2 row. See, number 12, at the very top of that row, I've got +2. So what I'm going to do is write a little +2 above the magnesium. Now I'm going to look up Cl, and I'm going to find out that it's in the column that has -1 above it. So I'm going to write a -1 above it. Okay? So this is almost like a balancing act. One side of our atom or our compound, one atom of it is +2, and the other atom is -1. In order to be neutral, to be balanced, to be a compound, you need to have the same amount of positives as we do negatives, because we need to be neutral. We need to have a 0 overall charge. So right now we've got a +2 and a -1. Well, those are not balanced. That means that our overall charge of this element or compound is a +1, because we've got one more positive than negative. So I'm going to show you a foolproof way that you never even have to think about it. So once we've got these charges, I do something called the crossover method, where you take this 2 and you put it down here, and you take this 1 and you put it down there. We just take the numbers, we don't take the charges. So it becomes mg, and see how I put that 1 down there? So it's going to be mg1 cl2. Because see how I took the 2 and I put it all the way down here. Okay? So the balanced element magnesium chloride is Mg1Cl2. We don't normally write 1s. So the real balanced would be M, if I can write it. MgCl2. That is magnesium chloride. Okay? So that is how you balance that. We're going to do a bunch more. I'm going to... I don't know if I can copy these. I can. I'm going to copy these to a note so that I can do this better for you. Okay, so our first one here is potassium nitride. So our first step is to figure out what potassium is, then to figure out what nitride is. Potassium is on the very first column. It's number 19, and it's a K. Okay, see right below where I've circled on that picture? So it's K, and it's in the +1 row. I'm going to do that right away. If I can write with this thing. For some reason it's not letting me. So we got it. I don't want it to do that. Maybe it won't let me write. So we got a K and we've got a +1. It was potassium nitride, so we got to look up what nitride is. Something that's going to be a little difficult here is that nitride is not on the periodic table, because remember when we put it in an element, we change that ending to "ide." So you got to find something that's nitra something. And there's really only one thing, which is nitrogen. Okay? So nitrogen is N, and it has a -3 charge because it's in that -3 column. All right. Now there's helicopters flying over. What a time here. So we got N, and it's got a -3. So this is potassium nitride. It's not balanced. To balance it, we don't even have to think about balancing unless you're a math genius, which I'm not. We just take the 3 and we put it down here, and we take this 1 and we put it down there. So it becomes K3 N1, and I don't need to write the 1. Whenever we write an element, if there's no number there, it's 1. We're not going to write the element if there's 0, because there would be no point. So it goes K3N. This is called the crossover method. When I used to teach in Saskatchewan, the students used to call it the whale method, because they thought that this looked sort of like a whale, if we were to, I guess, connect it. Or a fish or something. That's what they call it. They called the whale. So they'd be like, I'd be like, what do we do when we need to balance it? And they'd be like, do the whale. So that's what they came up with. But whatever works for you, that's how we do it. So let's go back to here. So the next one is strontium phosphide. So I'll write that right here. Strontium phosphide. All right. So our first job here again is to figure out what strontium is. It's going to be on the left side because it's the metal. Strontium is number 38 there. It's SR. And it's in the column that is +2. So see how everything in that yellow column on my periodic tables, that's a +2. So we would write SR +2. All right. Next is phosphide. So again, it's not phosphide. It's going to be something phospha because we changed that ending. And hopefully you realize that that's phosphorus, number 15, which is P. And it's in that -3 column. See the -3 at the top? That's the same column that phosphorus is in. So for this, we're going to write P. And we're going to write -3. So we've got strontium and we've got phosphide, and it's a +2 for strontium and a -3 for phosphide. They're not the same. So we do need to do that crossover method or the whale or whatever you want to call it. So this 3 comes down here and this 2 comes down here. So what does this become? It becomes SR3P2. All right. So we're taking those numbers when we cross over, but we're not taking the charges. So that's how we balance the element. Compound. Number 4 is lithium sulfide. We've done lithium already. So hopefully you remember what the symbol is for lithium, but if you don't, we can always go to the periodic table. It'll tell us all the answers. So lithium is in the very first row. It's Li. And everything in that first column there is +1. And then sulfide. Again, it's not sulfide. It's like sulfa something. It's sulfur, number 16. And it's in that -2 column. So if we got the -2, we've got the +1. They're not the same. So when they're not the same, we need to do the crossover. So we take our 2 and we put it down here. We take our 1 and we put it here. So this becomes lithium 2, sulfur 1. And we don't need to write the 1. If you wrote the 1, I wouldn't mark it wrong, but we don't technically. You won't see that when you see an element written like in a question that you're going to do. The last one here is sodium fluoride. So let's do that one. So sodium, maybe you already remember this one. Sodium is in the first column. It's Na. And it's got a +1. And fluoride is fluorine because it's got that ending changed, and it's F, and it's in the -1 column. So sodium with a +1, fluorine with a -1. So something here that's really important is that when your elements, it's their elements, when your elements have that same charge, +1 and -1, they're actually already balanced. So we don't need to cross over. We just need to write NaF. Because if you crossed over, 1 would go there, 1 would go there. Well, it's already balanced. The same thing happens when, let's do magnesium oxide. Magnesium is a +2 and oxide is a -1. So those are actually already balanced too. The two +2s and -2s, they balance each other out. So really the answer is actually just MgO. Some people like to go 2 and 2 and write Mg2O2. But if these numbers that you're seeing here are the same, you really don't have to write them. So this is the same as this. They're not needed. They don't need to be there. It's already balanced. Those numbers, those little subscripts they're called, the little numbers at the bottom, they're there to balance, and you don't need them if they're all the same because they're balanced already. All right? So just a note there. So technically, this is wrong. This MgO is the right answer. Okay, so let's get back to here. All right. So this is what they were talking about is polyatomic ions. Polyatomic ions always stay together during chemical reactions. As a result, they do not follow the typical naming rules of ionic or molecular compounds. So polyatomic ions, they're literally the same as any other ion. Just going to start my car. So they do not follow any of the typical, I guess they follow ionic in the sense that those 2 or 3 or however many elements together, they already have an overall charge. So these are not ones you have to remember. You'll always have them on this paper, or I will give you a some sort of data sheet that you'll have these on. All right. So how do we name them? Well, they're basically the same as we've been naming the other ionic elements, except for OMG. Having troubles here balancing my iPad. So how we name these, we literally will name the metal. So this would be our metal. And then we're going to name the polyatomic. So these would be the polyatomic. All right. So the metals are going to be on the periodic table just like before. So for this one, Al is aluminum. If you look that up, it's near the right-hand side. Na, we might already know that one, is sodium. And Ca, we've done that one today, is calcium. And then, so those are the metals. We've got those down. And then we've got to name the other thing there. And the other things are polyatomic. If there's more than one element together connected to a metal, then we know we have to go to that sheet. So if we go up in this, we're looking for SO3. So we look through this list to find SO3. So SO3 right there, it says it's sulfite. So just go down. So sulfite. So all I'm going to write is sulfite, if I can write. Sulfate. That's it. We don't need to worry about these little numbers because these little numbers are there for balancing. So we're only worried about the numbers that are sort of with that compound. So this one right here, that SO4, that 4 goes with the SO. Where here, there's brackets. They're just saying there's 3 of everything in the bracket. So those numbers that are outside the brackets, those aren't important to us when we're dealing with or naming these sort of things. So our next one is SO4. So if we go up, we look for SO4. It's right here. It's sulfate. And you might notice that I'm writing it pH and it says F. It doesn't matter. I don't care which way you write it. I'm just used to using pH. I guess that's the way I learned. But some sources will say F and some say pH. It's a difference in the, I think, British versus American. And then the last one is calcium PO4. So we need to look up what PO4 is on this thing. And we find PO4 to be right there. And it's phosphate. So we are going to write phosphate right here. All right, so that's aluminum sulfate, sodium sulfate, calcium phosphate. Okay, so that is where I'm going to stop for this video, because the next one is going to go on to a different sort of topic. The only thing here is that it didn't give you some examples of naming it from a word to the formula. So I'm going to let's do one example on the bottom here. Let's do, I'm going to write it right here. Potassium chlorite. How about that one? So our first job here, we need to, just like before, we need to write down these symbols for these things. So what is the symbol for potassium? What's the symbol for chlorite? So our metals are always going to be on our periodic table, and potassium, if you remember, is number 19, and it's K. It also has a +1 charge because it's in that first column. That's not a good spot to write. I'm going to write right here. So K has a +1. Now chlorite. Some of you might get confused. You'd be like, oh, chlorite. Well, it's got to be chlorine. The thing is that if it's chlorine, it should be chloride, not chlorite. That "ite" ending is telling you that it has to be a polyatomic. So we're going to look for chlorite in this table here, and we see chlorite is ClO2 with a -1 charge. So I'm going to write ClO2 with a -1 charge. So this is maybe a terrible one to choose, and as I wrote it down, I already realized that it's actually already balanced. Because it's got a +1 and a -1, our element together would just be KClO2. So the balance would be KClO2, and that's because if we cross these over, well, they're already balanced, -1, +1. All right? But the point of this is that I'm showing you that even they're exactly the same. You use them just like you would an ionic compound. It's just that this whole thing has a -1 charge. So it always goes together, stays together. And this might be the most difficult one for you guys to wrap your head around, and hopefully you'll get lots of practice in your assignment. And I'm not sure because I can't access it right now because I don't have internet, but I will post, I guess, something like this. So a table for you to be able to refer to, as well as which questions you're supposed to do that correspond with this video. All right. So I hope you have a great day and stay safe. And I will probably record more as the day goes on.